This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're talking about something that sounds backwards. The specification velocity paradox. Why loading up your AI prompt with constraints makes it faster, not slower. My fastest AI sessions were the ones where I overspecified. Here to dig into why, Claudine.
It really is counterintuitive, until you've lived through it a few dozen times. When you hand me a vague prompt, I have to guess. Naming, error handling, edge cases, what done even means. Every guess is a coin flip on whether it matches what's in your head. The misses come back as rework. Constraints aren't friction. They collapse my search space down to the answer you actually wanted.
It's like giving directions. Name the landmarks and the turns, I get there. Say head that way, you'll find it. Guaranteed wrong turn. But here's the skeptic's pushback. Doesn't specifying everything up front just relocate the time cost?
Sounds reasonable until you measure it, and the measurement breaks the same way every time. Writing a spec is linear. 20 minutes of thinking gets you 20 minutes of thinking. Done. Debugging a wrong generation is exponential. You read the code, run it, find the bug, reprompt me, I regenerate, you reread. And somewhere around round 3 you realize the whole approach was wrong. That's not a shift in where the time goes, it's a different cost curve entirely. And there's a second effect people miss. Writing the spec catches your own confusion. Half the time someone starts writing constraints and stops. Wait, I don't actually know what I want. That's the real win. Neither of us is about to spend an hour building the wrong thing.
I've felt that exact thing. Nailing the details clarifies my thinking. Guardrails for both of us. Can you make it concrete? A vague prompt that spirals versus a tight one that lands in one pass?
Take add retry logic to this API client, vague version. I'm guessing on every load-bearing detail. How many retries? Exponential backoff or fixed? Which errors are retriable? Do we respect a retry after header on 429s? Is idempotency a concern on posts? I pick reasonable defaults, and now we're in round 2 because you needed a circuit breaker. Now compare, retry gets up to 3 times, exponential backoff starting at 200 milliseconds, respect retry after on 429s. Never retry posts. Open a circuit breaker after 5 consecutive failures in a 60-second window. That's 40 seconds more typing. It collapses the whole problem to one generation. The thinking moves to the front, where it's cheap, not the back, where it's expensive.
Not more words, the right words. Turns an adjustment loop into a one-and-done pass. Does this change what a senior engineer's first move should be with AI tooling?
Yes, and for a subtler reason than I expected. Seniority is showing up in how someone frames the problem before they even type. Juniors describe the code they want. Seniors describe the invariants that must hold. A target gives me one thing to hit. Invariants give me a whole space to stay inside. The engineers getting the most out of me aren't the fastest typers. They're the ones who can say the constraints of a system out loud, which happens to be exactly the skill that made them senior in the first place. The thinking that used to happen quietly during code review now has to happen out loud, at the front.
Strategic framing matters more than raw coding speed. That's a real shift. So, how does someone catch themselves before they fall into that trap? Feeling productive while actually just accumulating rework?
The clearest signal is hearing yourself say close but more than once on the same task. That phrase is the sound of the trap closing. Each round feels like progress, but you're paying interest on spec debt you never wrote down. Another tell, the diff keeps growing while the requirements never do. If I'm generating more code than you're generating clarity, one of us is guessing. And the sneakiest one, you catch yourself editing my output instead of reprompting me. That feels efficient, like polishing, but you've accepted an architecture you didn't ask for. 3 tasks from now, you're fighting a shape you never chose.
So what's the actual recovery move once you notice you're stuck in that cycle?
Stop generating, close the file, put the prompt away, open a plain text document. Not because the document is magic. Leaving my context forces you back into yours. Write 3 things. What must be true when this is done? What must never happen? What's out of scope? That third one is the one people skip, and it's the one that saves you. A lot of rework comes from me quietly expanding the problem to fill a gap in the spec. Then bring those back as constraints, not a story. No, I was thinking maybe, just the invariants, flat and declarative. And the part that feels wrong until you try it, throw away everything from the bad rounds. That code is evidence of the wrong shape, not a foundation to build on.
Are there particular kinds of projects where this paradox really bites? Where a vague spec costs you the most?
Anywhere the code has memory, concurrency, state, migrations, anything, where the wrong shape can't just be edited out. With a pure function, a vague spec costs you a regeneration. With a database migration, it can cost you a restore from backup and an awkward conversation. 3 places it hits hardest. Concurrent code, where handle errors gracefully, can mean 7 threading models. Only one of them doesn't deadlock. Anything touching money or auth, the invariants are load-bearing and silent when violated. And long-lived refactors, I'm making dozens of small shape decisions per file that compound into each other. Being subtly wrong is worse than being obviously wrong. Subtly wrong ships. The moment code runs in production or touches data, you can't easily reconstruct. Those 20 minutes of specs become the cheapest 20 minutes in the project.
So how does a team build this into their workflow rather than it just being a personal habit?
The biggest shift is treating the spec as a first-class artifact, reviewed, not scribbled on the way to the real work. Pre-generation constraints get looked at by another human before I ever touch the task. Same way a design doc would. Sounds heavy, the review takes 3 minutes and catches misalignments worth 3 hours. Second, use a shared template. The same 3 headings: must be true, must never happen, out of scope, living in the repo next to the code, so the constraints ship with the change. And the hardest part is cultural. Stop rewarding, I got Claude to generate this in 10 minutes. Start rewarding, I got Claude to generate the right thing in 30. Those look identical on a stand-up update. Only one of them is actually done.
Claudine, this has been a genuinely useful reframe. As we close out, what's the one thing you want people to carry back to their editor?
The constraint isn't the tax on the work, it's the shape of the work. Every minute you spend making invariants explicit is a minute you're not arguing with a generation that misread you. More importantly, it's a minute you spend actually deciding what you want, which was always the real job. Next time you feel the urge to fire off a quick prompt, treat that urge as a signal. You haven't finished thinking yet. Finish the thought. Hand me the constraints. Let me fill in a well-defined space quickly and correctly. The paradox resolves the moment you stop measuring speed by how fast you type the prompt, and start measuring it by how few times you had to type it.
Finish the thought first, then generate. That's the line to remember. Claudine, thanks for breaking this down.
Anytime, Bill.
And to everyone listening, try it on your next task. Write down the constraints you already know are true before you write the prompt. See what changes. Until next time, happy coding. Claude Code Conversations is an AI Joe production. If you're building with AI or wanna be, we can help. Consulting, development, strategy, find us at aijoe.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.